All right, welcome everybody. We're now back to day 3 of our new last unit of the school year about universe and galaxies and maybe some space mission stuff as well. Number 1, what process and elements help form a star? Number 2, what process and element help to destroy a star? And 3, objects move away during what shift and move towards you during what shift? Feel free to answer in the chat if you'd like to contribute for the Go Blue. This will be on page 4. Answer includes for number 1, we all remember this from before, nuclear fusion, right? And that fuses both hydrogen and helium. Again, think of stars like a balloon expanding with that helium. Those are essential for star life. Now, what happens for star death? Well, some stars will explode, right? We call that a supernova, and that's caused by the element of iron, right? Metal element, okay? When iron builds up in a star, that's when it begins to get weakened, and it will collapse within itself and then potentially explode in what we call a supernova, right? Our star will probably not explode. It's probably just going to fizzle out like a light bulb, and that's because it's not like an average size star. It's more like a medium, lower than average size star, so a little too small for a supernova. And then the supermassive stars, the giant stars we call them, those can actually, instead of explode, not only do they explode, but they can also form a black hole. We'll get into that a little bit today. Okay. And then lastly, guys, what types of shifts are moving away and moving towards? We have what is called red shift, right? So that's red for the first fill in the blank on page 4, and then blue for the second one. Blue shift going towards you, and then red shift going away from you. Okay, so I'll leave it up for a moment, and we'll continue where we left off a little bit. Like I said, guys, I had a movie playing, but there were a lot of issues for our notes with the movie, so I'm going to try and have video clips loaded. Let me go ahead and do some of that now. I need to kind of look through some things real quick, guys, while you guys are getting that. So give me one moment here. Okay. Anybody else need to go blue? Got a picture? We're all good on that? Okay. Here is the table of contents, guys. Go ahead and update that. Go ahead and add pages 6 and 7. Tomorrow, we're going to talk about space radiation. Why is space full of radiation once you leave the atmosphere? Interesting stuff with that. Oh, my bad. So give me a moment, guys. I'm trying to load a few things here that I think will be helpful. All right. Well, I'm going to try and play the movie again. I think it's going to work this time. I just have faith in the movie. That's because the video clips, I don't think the videos help as much. We'll just see. I can YouTube search a few. But I like this movie a lot. You guys got a glimpse of it yesterday. So we'll check it out even further. Okay. So let's go do our first and maybe only question of the day. You need to answer this in the chat. We've got, what type of tide will form from the Earth, Moon, Sun setup shown on the right? So we have the sun on one side and the moon on another. They are working against each other to create tides. So will this cause A, spring tides, B, neap tides, C, high tides, or D, low tides? Again, what type of tides are created from the sun, moon, or setup? It's at a right angle, guys. See what you got. Again, if you want participation, you got to answer in the chat. Thank you, Lakia. I'll give you guys about 20 seconds. 20 seconds. Okay. Joseph, Giovanni, Diego, thank you. What type of tide will form? See what you guys have. See what you got. 10 seconds. You need to get participation credit to answer. You need to answer to get the credit. Okay, 5, 4, 3, 2, 1, 0. I want to give a shout out to Sanaya, Yorkies, Tatiana, Diego for getting the right answer. Everybody else, thank you for answering. Answer going to be letter B, neap tides. Again, why? Well, neap tides are more medium, right? They're not really high tides or low tides. Why? because the sun and the moon are working against each other, right? They're not working together to pull the same part of the earth. They're working against each other, which makes the tides, everything happy medium. Okay, so I want you guys to go back to page 3. If you need more room, go to page 5. We're going back to Into the Universe notes. So again, make page 5 Into the Universe notes. Okay, I want to talk about 2 more things today. Just 2 more things to write. We have the Milky Way galaxy, okay, and we have the our solar system. Okay, now remember, galaxies are larger than solar systems. Okay, and if you didn't know what a galaxy was, let me go ahead and pull this up here. Okay, if you didn't know what a galaxy was, it's these spirals in space. Okay, it's like a spiral in space, and that those spirals contain billions of stars. Our sun, again, here we see another picture of, these are called galaxies, right? These are massive. They're way larger than obviously solar systems. So there's billions of little solar systems inside of these spirals, okay? And believe it or not, in the middle of these, where there's really a lot of light, is a bunch of light and stars being consumed by a black hole. Okay, so let's check out the first part of our movie today. With that gets into the setup and how galaxies work. Okay, and whether these black holes are good or bad. Destroying a lot of stuff, so they're bad. But let's get some more details on them as a whole. What role they play in our solar system. So really, really hoping you guys can see this okay. Let me see here. 1 second. Okay, let me see if it shows it. I think it should show it now. If it doesn't, let me know. We'll find a way around this.
Around 300 million years after the Big Bang, the early stars began to form galaxies, which slowly took on a bewildering...
Is anybody having issues seeing our film?
Yeah, it's not working.
It's not showing?
No, it's still blank.
There's a black screen.
Oh, it's YouTube. It's YouTube movies. Okay, let me go ahead. Let me find it on YouTube. Let me find it in another YouTube video. Hold on. 1 second, everybody. Thanks for letting me know. Yeah, it's really good. I like this movie because it really kind of gives us like a spaceship view of like deep space and all this stuff. So let me go ahead. Hold on.
Did you buy it?
I bought the movie. Yeah, that's why.
Yeah, anything you buy, you can't share.
See, that's why there must be some sort of smart technology with Zoom or YouTube that's not letting it show over like a Zoom. That's smart though. That's smart for them. I bought this. Yeah. Okay. Let's see. Galaxies, Steven. And it's funny because this movie's kind of old, and they've got like the there's clips of it on YouTube. So I'm just okay. All right. So it looks like YouTube. It's not on YouTube. So I'm going to find my own galaxy video that kind of gives us a glimpse of what galaxies are all about, right? What are they? What's their makeup, right? So let's see. I've got a video here. Let's see what galaxies are made of, or galaxies explained. We'll do what galaxies are made of, basically. Hopefully this one, it's National Geographic, so it shouldn't be about 3 minutes. So give me 1 second here, wait for the advertisement to go away. All right. So instead of 10 minutes of our movie, we'll watch a 3-minute breakdown of galaxies in general, right? What they're made of. Not a huge fan of this, but we may just, let me see if I can find, it's kind of an old video. It's like 9 years old. So I'm like, I only wanted to show you guys good, cool stuff. So let's see here. Visiting. Super strange. But give me a moment, guys. Take a little breather. I'm gonna just try to find the best YouTube video I can find. Let's see, galaxies. Let me see. I'm gonna look up Milky Way galaxy. How about that? I bet we'll find something with that. Okay. Okay, let's see. 5 incredible facts about the Milky Way galaxy. That should be pretty cool. All right, so this will be a good one. About 4 minutes. Okay, waiting for the advertisement to be done here, guys. 1 second. It's a Geico advertisement. Okay, so give me 1 second here. Again, the 5 incredible facts about the Milky Way galaxy. We'll do this instead. Make sure you guys can see it on the screen, which you can. Let's check it out.
The Milky Way galaxy is an incredible 13 billion-year-old formation of billions of stars and planets, along with moons, asteroids, comets, and plenty of other fascinating things. All of this celestial beauty spans an estimated area of around 120,000 light years, and most importantly to us is the birthplace of humanity. So let's look at 5 incredible facts about this mighty system we call the Milky Way galaxy. Exoplanets are planets beyond our solar system, and scientists know they come in all kinds of different sizes. But the most interesting ones are those that are found orbiting a star within the habitable zone. The galaxy that we exist within, according to NASA, is estimated to have tens of billions of these types of planets. And even more exciting is that many of them could be small, rocky, Earth-like planets that might harbour life similar to ours.
Other life forms, right?
Our entire solar system orbits around the Sun in some way, but the Sun orbits around the centre of the Milky Way galaxy, which is so massive that it takes an estimated 250 million years for us to make one complete orbit, and this is known as a galactic year or cosmic year. Some
As you
studies
saw
have
there,
even
guys, really
suggested
cool. So all the solar systems, kind of like the planets with the sun, the planet and the sun are spinning, the planets are spinning around the sun, but all the other stars are spinning around each other in this galaxy. So it takes the Earth 365 days to go around the sun, but it takes our solar system, was it 100 million or 300 million years to just get around the center of the Milky Way galaxy. So everything's based off of a spiral. Really cool.
That because of this consistent movement around the galaxy's centre, our solar system might periodically run into some life-destroying situations, like massive asteroids or comets being forced into a collision course with the inner planets. The Milky Way is a barred spiral galaxy that spans an area of about 120,000 light years across, with a central bulge of about 12,000 light years thick. But if you could see the entire galaxy from a side view, you would notice that it is actually warped in shape. Scientists believe that this warping is actually caused by the Milky Way's 2 neighbouring galaxies, the Large and Small Magellanic Clouds. This pair of smaller orbiting galaxies are known as satellites, and appear to be interacting with the Milky Way's mysterious dark matter, resulting in this magnificent warped spiral effect.
Wow.
Our galaxy is a galactic cannibal, because it has gained its massive size by eating up other smaller galaxies over billions of years. Within the far reaches of the Milky Way's shell, studies suggest that leftover stars from previous acts of galactic cannibalism can even be found. And currently the Canis Major dwarf galaxy, which is the closest to us, is being added to the Milky Way's disk. This kind of galactic cannibalism is thought to occur because of tidal gravitational interactions, resulting in the 2 galaxies colliding and becoming one. Much like other large galaxies, the Milky Way has a supermassive black hole churning away at its galactic centre, around 26,000 light years from Earth. The black hole that lurks here is believed to be 14 million miles across and was detected by a massive source of radio waves. Observations of nearby galaxies have revealed that supermassive black holes are not uncommonly found within galactic centers, but the formation of such large black holes and how they affect the evolution of galaxies is still not fully understood.
All right, so we see there again the galaxy spinning. We see a bunch of other see all these little solar systems, right? These stars, they're all spinning around the galaxy and spinning within the galaxy. And in the middle there, right, we have a supermassive black hole. So think of this kind of like a space hurricane. It's like a space hurricane with the rain bands being all the stars and solar systems and planets, and with the middle, the eye being the black hole. Okay, so what I want you guys to write down for that. And I'm gonna make this shorter for you guys, so it's not as crazy here. Okay, so we're gonna go ahead, put Milky Way galaxy. I'm gonna cross off the first bullet point to make things easier. I'm not gonna ask you any questions on how old the Milky Way galaxy is, right? So we're just gonna cross that off here, right? Okay, but yeah, it is one of the oldest. It's like a really strong galaxy. It eats other galaxies, guys. Now, just so you know the design of it, we got to know, obviously, right here, right? Our solar system is located at the edge, so it's in kind of the outer parts of it. All right, so we're not in danger of being affected by the black hole that's in the middle. But in the middle, like I said, is a massive black hole. And people also say, oh, well, black holes come from stars, right? Yeah, but they only originate from massive massive stars, right? So you have to get a giant star to get a black hole, right? And our star is probably going to fizzle out. It's not going to explode in a supernova or from a black hole, probably. But when it does fizzle out, it'll get larger and maybe consume some of the rocky planets. So that's our biggest concern with that there. But again, in the middle of the galaxies are the largest black holes called the supermassive black holes, right? And lastly, guys, the black holes, they give off radiation and consume everything in space. So think of it kind of like a space drain, right? They're going to just kind of consume everything in their path, like light and matter. So again, kind of like a space drain. They're kind of mysterious, but we can kind of see, given the physics of how they work, it's like a space tornado, and it just destroys everything in its path. It's a way for, in my mind, it's a way for space to kind of recycle the dust, the stardust, and recycle all the stuff that's just sitting around. So kind of clean it out a little bit. So again, it's scary and bad, but it is good in the sense that the black hole keeps the galaxy organized, keeps it flowing. If there wasn't a black hole in the middle, you could see a bunch of solar systems and stars colliding together, and that would be very scary and bad for us. So it's keeping everything stable. All right, let's go to our next video and get into, well, I think let me find a cool quick video on black holes. I think that'll be, if we're talking about galaxies, right, why not get into black holes, right? So Black Holes 101. Oh, this is a 3-minute clip from National Geographic. I think this will be a really good video here.
At Go-Go Squeeze, we know life.
Okay. So this will give us a good rundown, because that was a part of the movie too. I didn't want to just show the galaxy without showing the science behind these black holes, which I think we'll have more days where we get more in depth on them as well. But let's get the basic rundown of them. One moment, everybody. One moment.
Black holes are among the most fascinating objects in our universe, and also the most mysterious. A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return beyond which we truly cannot see. Once something crosses the event horizon, it collapses into the black hole's singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply. Scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. stellar black holes form when massive stars die and collapse. They're roughly 10 to 20 times the mass of our sun and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our sun. Scientists can only guess how they form, but we do know they exist at the center of just about every large galaxy, including our own. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our sun. Because black holes are invisible, the only way for scientists to detect and study them is to observe their effect on nearby matter. This includes accretion disks, a disk of particles that form when gases and dust fall toward a black hole, and quasars, jets of particles that blast out of supermassive black holes. Black holes remained largely unknown until the 20th century. In 1916, using Einstein's general theory of relativity, a German physicist named Karl Schwarzschild calculated that any mass could become a black hole if it were compressed tightly enough. But it wasn't until 1971 when theory became reality. Astronomers studying the constellation Cygnus discovered the first black hole. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.
So again, a fascinating mystery in space. But again, we had astronomers looking out into space, and they were seeing like stars and like parts of space just go in like a warp, like this warping visual mechanism. And they kind of analyzed it further using physics, and they saw there's like these sort of space tornadoes draining and kind of taking in materials. So crazy cool stuff. Okay, the last thing I want to get into is solar system formation. I believe, let's see here, 1 second. Nope, we're gonna probably worry about that another day. 1 second, guys. Let me let's see, 1 second, everybody. Let me go ahead and find my last section. Okay. I want to get into nebulas. We'll talk about nebulas here, okay? So what are nebulas, and why are they relevant to our solar system? So we talk about black holes, galaxies, and now we've got another vocab word called nebulas before we call it. So let's check out my last video. Let me look up our last video of the day. 1 second, since the movie can't play it. And then we'll call it a day, everybody. So what is a nebula? I'm trying to find something that isn't too long. Okay. Nebula explained. How do nebula form? Okay. This might be, I mean, it's only got 6,000 views, so I'm a little skeptical about that. But I think it looks maybe promising. 1 second, everybody. Usually this is set up beforehand. Why not just show this? Why not? So I might not show, it's 9 minutes, but I may not show all of it. We'll just keep things concise. So why stars need nebulas, how the universe works. By the way, I'll explain it a little bit. Got another advertisement from Uber Eats. Very useful. Okay. Let's go check it out. Get into nebulas.
The Milky Way, a spiral galaxy full of regions of gas and dust called nebulas, and everyone has their favorite.
I really like the Horsehead Nebula. It just looks awesome.
The Cat's Eye Nebula has always been really captivating to me.
My favorite nebula is the Orion Nebula.
The Orion Nebula is perhaps the best place to understand the evolution of stars. And it's right here in our own backyard.
The Orion Nebula is maybe one of the most famous nebulas because you can go outside at night and see it with your own eyes.
Humans have been observing this fuzzy patch of sky for centuries. The Maya of Central America called it the fire of creation. The Maya were more right than they knew.
Almost every part of the life cycle of a star you can see in a nebula.
We can't understand the life cycle of stars without understanding the life cycle of nebulas. They are intertwined.
Orion has it all, from massive stars on the brink of death to newborn stars swaddled in gas.
You see the intricate wisps of material, the thin veils enveloping newborn stars, pillars colliding into each other. You see stars plowing through clouds of gas. You see this frenzied hive of activity operating right before our eyes.
With Fundrise, the same kind of real estate investments that have powered the world's strongest portfolios for decades are now available to you. From properties generating income today to development.
In 2018, using new data, NASA creates a groundbreaking 3D visualization of Orion's interior.
For the first time in history, we have the right tools to actually explore the hearts of these nebulas.
It was already beautiful to begin with, but now we have even more vivid images to really appreciate how great of a structure this is.
At Orion's heart lies a cluster of young stars. Together, they blast out charged particles in solar winds, blowing open a gap at the center, creating a window inside.
We actually see the structures and the volume. We can actually see the processes happening right before our eyes.
The cluster's intense starlight energizes the surrounding gas, causing it to glow pink and blue.
The pinks come from light emitted from hydrogen atoms in the nebula, glowing like the gas in a neon tube. The blues tend to come from the light from the hot new stars reflected off of...
kind of get a good idea of what nebulas are. If you want to watch more of that, go to Why Stars Need Nebulas by the Science Channel. I believe Science Channel, yeah. So really awesome stuff. This is the first time I've seen that video, and I really loved it so far. I want to watch the rest of it. Well, let's go keeping our lessons concise. Let's get our last notes for the day, which include all about nebulas. And I'm not a fan. Let me just get some better. The pictures I had on this slide last year, they ended up deleting somehow. So we kind of get some other better pictures in here. 1 second. Okay. One moment, guys. Let me get my pictures loaded here, and then we'll get ready to call it a day. All right. So here we go. All right. So guys, here we can see what are nebulas. Okay, nebulas. And guys, we're gonna write this on page 5. So make sure you write nebula and then the notes below. For nebulas, just so you understand. Okay, take a picture if you like, guys. Again. They're basically a cloud of stardust and star gas from when stars have exploded after a supernova. So it's like the debris of a supernova, right? What's left over, okay? So this dust, it floats around endlessly in space. But sometimes this dust can reignite a new baby star, okay? So it's just a way for the stars to get recycled. Old stars die, and then they can become new stars. And yeah, keep in mind black holes, guys. They're important because they help anchor galaxies and cause them to be spiral in shape. So that's important, right? So yeah, even though black holes are largely a scary negative thing, right? We think that, oh, they're going to destroy us or they're going to destroy space. They actually serve a purpose. They keep They help to keep the galaxies from having structure. They keep if there was no massive black hole in the middle of the galaxy, it would cause all the stars to maybe collide and just go all over the place. So we don't want that, right? That'd be bad for our solar system. Okay, that is it for the day. we're gonna stop right there because this has been a longer lesson. But let's go ahead, take a picture of that if you haven't already. You need all of that. We talked about again, galaxies, black holes, and nebulas. So that was today's lesson. Keeping things concise to one question a day. We'll go ahead. Let me go ahead and know what's diamonds due tomorrow, guys. I think we might play a little review game, maybe potentially with more of our lessons. But let's go. Let me double check attendance here.